Bonjour à tous les amis, j'espère que vous allez bien, c'est Fractal. Aujourd'hui on est avec un article sur Rust qui nous parle de game développement. On va parler de Abstraction Isn't a Choice. Donc c'est deux game dev qui sont tout simplement qu'on fait leur jeu pendant 3 ans en Rust et qui donnent leurs conclusions, sachant qu'ils reviennent vers Unity. Donc c'est hyper intéressant, on en apprend sur Unity, sur ce qu'ils aiment, le workflow, le game dev. Tout ça c'est hyper intéressant et on va découvrir ça. Donc Abstraction isn't a choice, donc l'abstraction n'est pas un choix. On est parti.
Abstraction isn't a choice. This section is motivated by a very simple code sample I just wrote while working on our game. I have a UI with a list of characters and a detail page that appears when a character, duck, is selected. The way the UI is structured, I just have helper functions for each state of the UI. As we're using a GUI, an immediate mode requires most things to be available in most places. This actually works great, because things like this will work, but let's say some of these have conditional state, and their implementation is actually quite non-trivial. This is the case when selecting a specific duck. Initially, my code was the following: is again works fine. Problem is a GUI will often require very deep nesting just because almost every layout operation is a closure. It would be very nice if we could reduce the nesting and move the if outside. As a result, we'd also separate out two clearly separate things, first instinct. But here we get slapped on the wrist. Did I actually think I could get away with passing self around while also borrowing a field on self? Even years into using Rust, I still sometimes use too much of my brain thinking about the UI or game, and too little thinking about how I should be structuring my code, and end up with a problem like this. The Rust Y instinct would say, clearly you need to separate your state and not pass around a big struct. But this is a great example of how Rust clashes with the most natural way of doing things. Because in this case, we're building a single UI window. I don't want to spend any of my brain cycles thinking about what parts of the UI need what parts of the state. I just want to pass my state around, it's not that big. I also don't want to spend extra time passing around more fields, when I add more fields 15 minutes down the line, which I'm almost certain I'll do. I also don't want to be separating things into more than one struct, because there's more than one thing I might want to do an if on. And having gone down the splitting structs path before, it rarely works out on first try. The solution? As many things in Rust, we feel a bit of the clown face emotion, clown emoji for those who don't have the right installed, and then change the code to this. Everything now works, the borrow checker is happy, and we're cloning a string every frame. It won't show up in the profiler, so it really doesn't matter in the grand scheme of things. But it's especially sad for a language that aims to be so fast and optimal to have to resolve to wasting cycles on reallocating memory more often than one would like, just to stay productive. I only mention this specific case because it's quite indicative of my overall experience writing Rust, and where many problems are simply solved by extra copying or cloning. It's something most Rust developers are familiar with, but that came as a surprise to many people I was helping learn Rust. Their usual response is, wait, I thought Rust was supposed to be very fast and efficient. All one can say to that is, oh, it is fast. Don't worry. In this case, cloning the string every frame is totally harmless, and then feel the clown face emotion again.
Donc effectivement, une manière de taire le borrow checker, c'est de mettre des clones partout. D'ailleurs, la plupart des gens écrivent d'abord leur première version de leur code avec des clones partout, puis après eh bien ils essaient de les enlever et effectivement des fois c'est trop de douleur de les enlever et au final oui il faudrait faire les choses parfaites mais tu veux pas refactorer tout ton code, du coup eh ben t'en laisses ceux qui coûtent cher d'enlever et qui coûtent pas cher en profiling, tu les laisses et au final tu copies bêtement des choses juste pour taire le borrow checker. C'est un peu triste, mais c'est la seule façon d'être productif en Rust, effectivement. Et tu te sens un peu bête, quoi. Parce que globalement, tu as éteint un warning de Rust qui n'aurait pas lieu d'être. Parce que tu t'aurais pu très bien ne pas faire cette copie et est-ce que ça aurait été un problème? C'est une copie inutile juste pour pouvoir ne pas avoir refactoré et tu te retrouves à faire ça régulièrement. Un très bon exemple je pense.